our next speakers are Eric and Jelmer. They're from Kramp. I think I pronounced that. Not bad, not bad. Yes. And they're going to be talking about increasing relevant product recall through smart use of customer behavioral data. They're in the e-commerce space up in the Netherlands. And Eric is a product manager and Jelmer is an architect. So without further ado, gentlemen.
Thank you. Is the mic working? Very good. Okay, yeah, first of all, thanks for having us here at Haystack. I hope to give you like a practical example of how we're trying to improve the relevance in our e-commerce industry. Hopefully we have some nice things to share for you to learn, and also we would love to hear your feedback and input afterwards. So already Charlie, he introduced us, so not a lot of introduction left, but indeed we both work for Kramp. Myself as a product manager on the product findability domain, we call it, with multiple teams. And Jelmer as an architect, also working on data, machine learning, and part of the work he's doing also on search. So we'll do this presentation together. So today I do want to give you a bit of context about Kramp and Kramp Hub. I think most of you or all of you have never heard of Kramp, and don't worry, that happens a lot. But we're actually one of the bigger B2B companies in the Netherlands and active across all Europe. So I do want to give you that context so you also know why we have the challenges we have and why we built a solution that we have. And also the solution, we have some nice A/B testing results and some metrics to show you how we measure our success. So those results will also be shared at the end of the presentation. So about Kramp or Kramp Group, the biggest organization within Kramp Group is Kramp, and we are a wholesaler active in the agricultural industry and some other industries adjacent to it. We actually did a little over $1 billion of turnover last year. That was our best year ever. So we have roughly 50,000 customers. Those are not the numbers you usually see at the bigger B2C companies, but these, yeah, it's a B2B world. So these customers we have, they are their organization as well, where multiple people are purchasing from us. Bit over 3,000 employees. We're active in 30 countries, 11 distribution centers. So we're good at getting the stuff to the customer the next day. That's actually one of the USPs we have. And the big challenges we have is that we have a lot of products, roughly 500,000 active in each country, but 1.7 million in total. So besides having a lot of languages to deal with, we also have like specific country assortment to deal with. At Kramp Hub, so we actually have our little, let's say, tech startup within our organization. We founded in 2017 in the heart of Utrecht. Also because the big company of us is located in the eastern part of the Netherlands, but Utrecht is actually where a lot of people want to live. So we have a lot of people relocated to Utrecht. At this moment, roughly 75 colleagues in Kramp Hub, over 25 nationalities, so really diverse organization at the moment, and we are with a little over 10, depending on the moment you ask us, but at the moment I think it's actually 11 agile teams. And we're building a platform. So a microservice e-commerce platform. We're powering multiple channels, so that Kramp webshop is one, the Kramp app is one, and we have some other channels that we actually power from our platform. And for search, we have an elastic core, but with microservices on top. So microservice for search, for the autocomplete suggestions, recommendations, like that. And then the last context slide. So we have we talk about a typical customer of Kramp. You can think of a tractor dealership. So they usually have, you know, a workplace where they have like mechanics working there. There's usually one person in charge of doing the purchasing. So when they start a day, they log in to the Kramp web shop and they are active during the whole day, purchasing parts throughout the whole day. They're often very loyal. So we have customers with us for 25, 30 years. Kramp is actually 70 years old. So we're a really old company. And those customers are really knowledgeable because they've been in this industry for a long, most of them a long time. They know what they need. They search for specific parts, and they also trust the expertise of Kramp. So they trust us to present them the right products, the right parts that fit their specific needs or their specific machines. And that's a good thing to remember with the challenges that we have. Actually, and some numbers on the search. So we have a little under 4 million unique queries a month across 20 languages. 80% of our add to carts actually start with doing a search. And the big number here for us and the big opportunity that we still have, even though we've been working with teams on searches, that roughly 60% of our searches do not lead to any product interaction. That could be a part of it because we just don't carry that assortment in that specific country, but there's a lot of opportunity to improve. Yeah, and then 2018, actually, we built the search as the first service in our e-commerce platform roughly 4 years ago. And while doing so, we encountered quite some challenges. And then I'm handing over to Jelmer.
Yeah, so indeed, there were a lot of challenges that we suddenly had to deal with. Okay, so we're going back to 2018. What's the situation? Kramp just started. It was search was the first thing that was rolled out to actual customers of our new e-commerce platform, and it was really cool. But then we found that actually, the product data was lacking in some aspects. For example, some products only had like a title, maybe not even an image. They were just, these products were called like bolt or like screw or nut. Right? I mean, that's sort of a difficult starting point if you want to do search, because you want to sort of index all these documents and you want to search through them, and someone queries, does a search, and then you look through your documents. And then when the documents only say stuff like bolt, how do you know which ones are important to a customer? So yeah, product data was definitely a problem. So we tried to fix the search results manually, adding synonyms and doing suppressing search results, or what else did we do? Like manual intervention and curation of the results. But given the scale of the catalog, it's 1.7 million products. So you need a whole lot of people, to sort of manage search results. And even if the product data was good, by the way, then you're never going to sort of get matches on all possible search terms syntactically. I'm saying that because we were not doing semantic stuff, because vector search in 2018 was not really a thing. I mean, it was a concept, and it felt like something that was like really far away. Like, we are not going to do that this year. So basically what we did was tractor search, not vector search. So I'm going to make dad jokes like during the entire thing. And also, yeah, like I said, we were a startup. We had only been around for a year in 2018. So that's quite short. There was nothing there. Basically, all we had was search, and all the other services were under construction. So there was nothing there. So that's a really suboptimal starting point, right? So then at some point, someone just said, this is a literal quote. I don't know if they meant it positively or negatively, but what they said was, this is sort of the end point. There's no way we can possibly improve search any more than like what we're currently doing. So thank you for your attention. If there are any questions, we have plenty of time for them. But wait, no. There were some sort of assets already that we had that we could leverage. We had a few epiphanies. One was, well, actually, we have customers that are basically always right. Why are they always right? Well, they are special, these B2B customers, because like Eric just described, we have a really long-term relation with them. They've been customers for years. They come to the web shop a lot, they buy a lot of stuff, and they are very determined to find what they're looking for. Because actually these people, they're not browsing for inspiration. It's not Pinterest or any like B2C thing where you want to pick out drapes or carpets. These people have a lot of technical knowledge because they want to buy very technical parts. You cannot get inspiration. It's not like an inspirational thing to go and browse for parts that might look good on your tractor. They have to fit exactly, there are specifications, like dimensions and stuff. So anyways, these customers basically know better than I do, at least, what they're looking for. So yeah, there must be value in that, right? Secondly, we had another epiphany. And this is where I'm quoting myself. from 2 slides ago, our entire landscape was under construction. There was nothing there. And that's actually a really great thing. I mean, there was no legacy stuff keeping us back, holding us back. It was just, there's sort of a blank sheet of paper where you can sort of, I don't know, imagine the future and build it. You know, we could do anything. So we decided that the solution would be, you know, in the absence of good product data, that we were going to let our customers sort of fill in the gaps and tell us what's relevant, because these people know, we don't. We have e-commerce domain knowledge. We don't know about tractor parts. I don't. So rather than, you know, asking them directly, doing a survey with every search or sending surveys through email or whatever, we decided to sort of implicitly, you know, gather information for them from them by observing their behavior. Because that behavior, you know, it's definitely not random behavior. It means something. They're looking for something specific. And, you know, if they can tell us what that is, then we can sort of incorporate that into search. So these were our starting points. Customers produce events, which we were capturing. You know, like searches, clicks, price checks, stock checks. They interact with a lot of products. They search for a lot of terms, and all these events, you know, by themselves, they don't really mean much. But if you sort of evaluate these events in the context of a session by grouping them together, then it's likely that you're going to see some cohesion, some patterns, right? And also, if you look at these sessions, you can also very easily calculate metrics. So it's always nice to sort of have numbers that tell you how well you're doing. And in these sessions, there are also the, you know, they capture all the interactions with our search. So let's start at the start. We have these customers producing events. These events are not random. They mean something. This guy really wants to get to his part that he's looking for, because if he doesn't find it, then he needs to go to some other web shop, to a competitor, and he doesn't want to. So he's really determined to find it at Kramp.com. So if you put all of these events together in a group, you get sessions. And the way we approach sessions is basically we do micro sessions. So each micro session that is about search always starts with a search event that is being published by our search service. And then the rest of the session is basically everything that comes after that, every interaction with products or clicking category pages or doing whatever they're doing, price checking. And we decided that the session should be short, so you can really sort of get an idea of cause and effect. I mean, if you take a day-long session and capture everything that a customer does in one day, what kind of information is in there? I mean, the signal sort of gets lost in all that information. So we make short sessions, and we say, if someone is idle for, let's say, 2 or 3 minutes, the session will have ended. So these sessions are, the first thing we use them for is to calculate metrics. So these metrics describe what the outcome was of a full session in its entirety. So you have a search, always starts with a search. Stuff happens, and then after it has happened, we look at it and say, okay, what kind of metrics can we calculate out of this group of events? And there are some really simple yet effective metrics that you can calculate, like a session has an add to cart, yes or no, or it has interaction with items, with products that were in the search results, yes or no. We also have the concept of indirect, like direct versus indirect interactions, because I saw that very often people search for stuff, then they get results back, and then they click and they click and they do stuff, and then in the end they buy something. And often I noticed that the thing that they bought was not even in the search results. But given that these sessions have a sort of like a really small scope, a really narrow scope, we sort of assume that there is something there. They're doing this for a reason, right? But yeah, so on these groups of events, we calculate a bunch of metrics. We also do our own interpretation of NDCG. I've seen NDCG discussed in one of the previous presentations. And the way we approach it is basically that we assign a value that only sort of means something within the scope of a session. So we can calculate an NDCG value for each search that happens by just looking at, okay, so this was the list of results. And then all of the products out of those results that were actually interacted with or bought, they get a score, like a relevance score. And then we do the sort of the normal NDCG calculation. I don't know if this is something that other people would really disapprove of, or if you guys think it makes sense, but this is how we approached it. So now we have events grouped into sessions, producing metrics. So how do we do this? No, wait, I'm getting ahead of myself. First, Eric is going to describe sort of what really a customer sort of journey looks like and the kind of stuff that happens in these sessions.
Yeah, I'll jump on the stage with you.
Yeah.
Cool. Yeah. So practically, we know from customer research actually what's at least scenarios that are going on here. So we have a customer, let's say they search for this fictive term of A123. They don't find what they need because there is no interaction at all. And then from research, we know that they, and also from data, sometimes we can tell that they do different actions then. So they could search for another word or another term. So that's searching for synonyms and eventually finding the product they need. They could start browsing. So they could click on a product and then use the breadcrumb to go back to categories. And from there, look for the item that he actually intended to find in the first place. We actually get a lot of calls to our product specialists. So in every country, we have like people, sales representatives trained to know all about tractor parts. But often customers just call telling them, okay, I cannot find what I need. This is what I need. Please tell me the number I need to look up on the web shop to actually put it in my cart. Or they look it up in paper catalogs. And that might sound very ancient to you, but trust me, a lot of customers still have like duct tape together parts catalogs under their desks and they use them every day. So let's say they look up, the part that they need in that catalog, find the number, because a lot of, I think roughly 50% of our queries are numbers, and then they start looking for that. So there are many scenarios, of course, other sources on the web as well. Let's say in the end, they find a certain term or a certain number for which they do find the product they need and they add it to cart. So in that sense, they have they've done multiple actions, where they started. So that's with that search for A123. And if we have a number of unique customers, showing the same pattern, the same type of behavior there, we make the link. So we made the connection between the product that they added to cart at some point, and we immediately show that product when a customer, let's say the next customer, searches for A123. So we're enriching the search result by doing so.
Yeah, but the thing is, so the graph that we just saw, the diagram is sort of hard to analyze, right? But we have these sessions, which are just, sequences of events. And a much easier way to analyze these sessions is to just split them up into tuples, where, the left part is always going to be the search, and the right part is going to be every other thing that happened in the session. So what we do is we just split these sessions into tuples of search and some other event, and then we also give them an interaction score. So an interaction score is sort of basically like what we also use in our version of NDCG. What we do is we use a number that is the equivalent of the correlation of a certain type of event happening in session and an add to cart happening in the same session. I thought that made sense, right? So that's why an add to cart gets a 1, because if an add to cart occurs in the session, then an add to cart will have occurred in the session. And, the other things are sort of signals, like price checks or availability checks, stock checks, product page clicks. They might contribute to lead up to an add to cart eventually, but sometimes they don't. So they get a lower score. So these tuples are produced in our data collection setup. So what we do is we have events coming from the front end. So these are the clicks and the price checks and the add to carts. From the back end, we send very rich search events, which describe who was searching, when, which index, which language, what was the search term, which results did they get back, what was sort of the hidden set of results that they didn't see because they only saw the first 15 or 30 results. So we've got these really nice events, and they tell us a lot about how the search went and what was returned. And we feed them all into a big real-time streaming pipeline, consuming all these events that are being published onto PubSub. And this is called the sessionizer. And that's where we, in the case of search, we say, okay, a search session looks like this. We have a search event and everything that comes after. If someone does nothing for a few minutes, then the session is done. And then we publish these sessions. So usually they get published, let's say 3 minutes after they happen, because we will have observed that someone was not doing anything. And then immediately they get analyzed by our evaluator. And this evaluator does two things: calculate metrics, like there was an add to cart, yes or no. There were results, there was interaction. And the evaluator also does the splitting into tuples. And then we just land them into our data platform in BigQuery, basically. So that's our setup. It's really nice because it's, it may look like something you don't want to do. Like, why do we want real-time streaming analytics to happen? You can just do a query. You can just put all the events here and then do a query on it. But that would be a very awkward, long, unreadable query. We found that it's much easier to just deal with streams of events, chop them into sessions, group them into sessions, and then look at these groups one by one, because it's sort of, you don't really need a lot of resources for that. I mean, like Eric said, we have 50,000 customers and they produce a lot of events, but it's manageable. We just do this with like very small machines. So yeah, this is how we get our data about what customers actually do. And yeah, so the next thing is I'm going to explain how we get to the insight that there might be a connection between something that someone searches and something that someone can buy, or a product. So we have all these tuples and we interpret them in this way. So we know from the search which search term was used and in which language. And then we see, okay, so there was an interaction with product Y. Before that, there was search term X. We give it score Z, and this tells us how important this interaction was. So this is how we look at each individual tuple. And then, because like I said, we have very special customers who know exactly what they're doing. And as such, they can provide this information. What we do is we just put all the tuples we produce in a big pile. And we start counting. How many times did we observe that search term X led to an interaction with product Y? If it happens more than some number of times, then we decide that it's important. And we also look at stuff like, okay, we need to have observed this at least in a number of unique customers. Like if it's just one guy doing it, we're not going to take it into account because it might be a guy or a girl just trying to mess with us. I've actually seen this in the data. I've seen search terms that were like, is Jelmer actually reading this? Is Eric reading this? I swear I've seen this. So yeah, if one person tries to mess with us, fine, go ahead, mess with us. We don't take the data that you produce seriously. But if we observe it in a number of customers a number of times, and if the score, the interaction score, the average or the aggregation of it is sufficient, then we say, okay, we're just going to add this search term that was used to get to this product. We're going to put it directly into the product document in Elastic. And from then on, everyone who uses this search term can get to this product directly by just entering the search term. And it's really interesting to see what people do, because I think some of the search terms that we have mapped onto items actually contain stuff like asterisks and like wildcards. And it's really funny because it's sort of saying like, hey, this system works however you want it to work. I mean, just enter anything, and after a while we will sort of catch on and we will feed you your results that you are actually after. So this process of taking all those tuples, aggregating them, counting them, is a very simple process. So what we do is we have all of this data in the data platform. We do an analytical query where it's just, group by language, group by search term, group by item. And then we aggregate that using a data flow pipeline, a batch pipeline that runs daily. So we get daily updates about all of the insights that our customers are giving to us. We publish it to PubSub, and then it gets consumed and added to the Elastic index in our search service. So yeah, that's what we do. And 3 years ago, when we rolled this out, we actually did something that was also interesting. I think I have time to explain a little bit of it. So we sort of pre-tested this new functionality of mapping search terms to individual products. We pre-tested it using simulated customer behavior. So we didn't just run historical sessions through like past search to see what the results would be. We actually generated new behaviors based on all the session properties, because it's really easy to create a Markov like a state transition sort of matrix out of these sessions, because it's you just transition from search into clicking some item, and then once you click that item, there are a number of things that are likely to happen after that. So using those Markov principles, you can just generate all kinds of synthetic sessions and just test your new search features by evaluating those sessions. And this is all sort of assuming that the add to cart ratio is a given. It's not going to improve or it's not going to increase or decrease in these simulated sessions. And there's no need for it to, because we know our customers are determined they want to do that add to cart, so that's going to happen anyway. All we can do is sort of make it easier for them to get to that add to cart button on the right product. So we pre-tested this, it looked promising, and then we tested it for real using a multi-armed bandit service that we built. So initially we just did what we always did for 90% of all traffic. And in 10% of all cases, we sort of did this new thing where we do the mappings. We add the mappings to the index. And then quite soon it became apparent that the alternative was actually much better for interactions with products, for I think also the add to cart ratio for the NDCG. So the multi-armed bandit service that we had at that moment, it's just switched like, okay, from now on 90% of all traffic gets these mappings because they are useful with regard to if you look at the metrics that are produced by these customers that get this feature. So yeah, that's what we did, and that's what happened. And now Eric is going to dive into the results and what this actually looks like.
Cool. Let's dive. Okay, so what does it practically look for a customer? So I have some examples of what the relevance mappings actually look like. So a customer searches for Muthing. Now, I didn't know this, but the product specialists tell me that that's the brand of these type of machines over there. And that's a flail mower, also that I didn't know. So without the relevance mappings, we just have 0 results for this hit. There is no mention of the word Muthing in any of our product data, any of our corpus at all. But if you look at the relevance mappings, over time we did this actually grew. So this is a search query that we tracked over time, and these parts, you got to trust me, they fit underneath that machine over there. And this is this paint is called Narcissengelb. So that's at least yellow paint. So it appears that this is indeed the products that fit these machines. So there you see actually the value of making sure that we don't have as many 0 results as we used to have. Another way the relevance mappings help is making sure that we show more relevant assortment in certain countries. So Makita is actually the brand of power tools. Pretty well known, but for some reason Kramp doesn't carry that assortment, probably commercial reasons. That's fine. We do carry a lot of assortment from other brands in the power tool range. So if you search for Makita in the Netherlands, apparently the Dutch love Hikoki because that's the brand of power tools that you actually see a lot of results from pop up here. This is all based on actually the customer behavior data and the mappings that were implemented. Could be that some of the results mixed in here also, matching still on the product data itself. But when you compare it to the search term Makita in France, actually you see that the French people, they prefer the brand DeWalt, because that's another brand that we sell in the power tools. And right now, those are the products that appear on the surface. And looking at Germany, the third brand of power tools that we sell, and we have a big range, as you can see. Sometimes these brands also differ per country, but here actually Milwaukee is showing up. So in all 3 countries, you don't sell Makita, but based on customer behavior, so over time, a customer was searching for Makita, didn't find anything, and in the end, they did do a click or an add to cart. They did somehow end up at these Milwaukee tools, and enough customers had this behavior, so we're showing these results. However, we know, and it's I think also to you pretty apparent, that we cannot be right 100% of the time, right? So we have tried to figure out which configuration to use to get the relevance results up. But there were some complaints because we were showing some incorrect products sometimes in the search results. Now, for a query like Makita showing a wrong power tool or maybe a wrong product, there is not that big of a deal. But if a customer searches for a specific part or a very specific part number, and we're showing a product that looks like it fits, but it doesn't fit, that can be a very big deal. So this actually, these complaints landed on our desk, and we tried to fix them where possible. This also led to calls to our specialists, because customers, they see a result that doesn't really, they doubt, so they start calling. And even some of these products being returned because it turned out when they got the product that wasn't the right part. So we know we need to make adjustments there. Still, we are very convinced, also because of the first test that we did that Jelmer was talking about with the rollout, that is, in general, this functionality has a very positive impact. But because the way we are currently setting up our testing, we weren't able to show that right away. So what we did is we did another A/B test pretty recently, I think half a year ago, for the same functionality, just to have the evidence, right? How much impact this functionality still makes. So here's an example of a search result page, a customer search for an item number. You see the top results; those are there because those products, they have a match in the core product data. All the products underneath are a result of our relevance mappings, but you see that 2 of the results shouldn't be there. So that we know this from our product specialist. Those two results should be out, and actually are a problem for our customers. They might lead to complaints. So in our control version of the A/B test, we just kept everything active. So that's as it was beforehand. So that's the version with our relevance mappings, and in the variant, for 3 weeks we disabled. For 50% of all our customers across all countries, we disabled this functionality. And then, of course, we had to see what would happen. Looking at the results, we were very happy with this. It's a very good outcome. So there were 2 key metrics that we tracked: product interactions and add to carts after search. So with the product interactions, we see a difference of it says minus a little over 5%. Actually, a good thing, because our control version was the version where the functionality was active. And the result is significant. So we do see that there are over 5% more product interactions with this functionality enabled, which is for our search a lot. It's a really big impact. And add to cart, a little smaller, but still 3.5% difference is a huge amount of turnover for our company. The difference between the interactions and add to cart is also the price check and the stock check. So we know a lot of customers, when they find what they need, they will still look at price, or they will look at availability. And often, if they can get the part the next day, they will still try to look for something else. So that does explain the differences. A nice side effect that we saw, that we also tracked, is that it has an impact on the 0 search results pages. So with the functionality disabled for the 50% group, actually we had 20,000 additional 0 result pages showing up. So that doesn't say that with every 0 result page that we now prevent, we show only relevant results, but that the majority of the 0 result pages that we know of, at least, they get relevant results due to this functionality. So the conclusion, we see there is a lot of value and insights from this customer behavior. And relevance mappings, they do improve our search relevance. We can't afford to switch it off looking at the results, but we do need to fine tune the algorithm. We have a functionality now in place in which product specialists can actually indicate which results are wrong. And this is not the reason we have this functionality in place. It's not because we want to create this work, but we have the feedback, right? We get the feedback loop going. We understand which products shouldn't be there. And we can adjust our algorithm to make sure that we improve over time. So that's something that's happening now where our product specialists are helping us to really improve the technology. Yeah, now with the next steps, so we already have some modifications to the algorithm planned. Maybe we might exclude some incorrect mappings. That's actually the goal, to make sure that that's going to happen. We can fine tune the criteria, maybe set the thresholds a little higher. So we're going to start A/B testing with this to see if it actually leads to less complaints, but then still the same or even better product interactions and add to carts. And the last part, Jelmer?
Yeah, and so in addition to, we're gonna change the algorithm a bit. I'm actually hesitant to call it an algorithm. It's a query. It's okay. But due to us investing at an early stage, mostly into our data collection setup, making that a solid foundation, we now have billions of examples of people doing something and then doing something else, and all the relations are sort of in the data. So I'm seeing a lot of opportunity to further leverage all this data that we've collected over the last 4 years. And we can even sort of dive into vector search now, because we have all these examples, right? So we can actually create those fine-tuning models because we have examples of queries and examples of products that were sort of relevant to that query. So I see no reason not to sort of further dive into this. So and also, like I said, we have this real-time insights pipeline. So if we decide that we want to do something based on the last 10 products that someone visited in the last like today, we also have that available. So there's a lot of fun stuff that we can do looking at the future. Yeah, but for now, what we've presented is basically like a way to fill in the gaps of missing product data with let's call it a who searched also bought recommendation like algorithm, calling it an algorithm again. But yeah, I think this is our last slide, isn't it? I'm gonna hit the space bar. Let's see what happens. It's done. Thanks for your attention. Feel free to get in touch.
Thank you, Eric and Jelmer. Thank you very much. Fascinating stuff. So we're going to go to some questions now. Do we have anyone in? Oh, right away, we have a question.
A question regarding the example with Makita versus Milwaukee. So have you had these Makita products out of stock, like temporary, or was it a permanent issue? How is your A/B test concluded based on including this example where you're showing to the customers completely different brand? Thank you.
Yeah, we showed this stuff during the A/B test, and now we show it all the time. And the reason the term Makita didn't give any results was basically because Kramp doesn't sell it. But it's a well-known brand of power tools, so people are likely to just look for it. Can I get some Makita power tools? But then they don't find them, they find something else, and then that gives us clues that there might be other power tools in our assortment that are relevant to this query.
I'm not exactly sure the commercial reason from category management why they don't put the Makita stuff on stock. I think we have agreements with the other brands, so that's why we cannot carry that assortment. So that's why. That's definitely not zero. We have had multiple times like this. There should be, yeah. In the end, if we know the intent, we could also start playing around with that. Actually, getting more information out there to help the customer understand why they see what they see. But for now, it's just.
Thank you. So I've got some questions from our online audience. I'm going to try and get through some of those as well. Rick asks, how do you incorporate phone calls to Kramp and the resumed search into one session?
So the phone calls are pretty, so we don't track those. We know that this behavior happens by talking to customers. So the big diagram that you saw, we don't know what's going on between search number 1 and search number 2 per search event, but we do know that customers go to great lengths to find the product that they need and buy it on Kramp, because that's where they typically buy the stuff. So yeah, that's something we cannot track or.
Thank you.
Hi, thank you for your speech. It was really very interesting. I just wanted to ask you, maybe you could share any other results, what has changed while implementing this model in production? Because like, how do you sell to your customers that they need to do this stuff in their search engine? How do you tell them that this will increase quality? Because from my perspective, I always face up situations when I say, this is a technical stuff, this will increase like your algorithms, but they say, oh, we don't want to like spend money and time on this. So maybe you could share some results or some points you share with your clients.
Oh yeah, but we don't actually require customers to do anything other than what they were already gonna do. It's just that we are observing them doing it and they don't notice. So we don't ask anything of them. We just observe, we're just hiding behind the bushes. Okay, so they searched this and then they bought that. So yeah, I'm gonna write that down in my database of stuff that I now know. Does that answer your question or?
Maybe you should just share some more results.
But wouldn't sharing results with customers, that actually opens the door for people actually trying to mess with us. If we explain to them, hey, this is what we're doing, then there might be competitors with accounts that are like, okay, we're going to mess everything up now. I'm not sure I want to, you're the product manager. up to you.
Okay, so we've got another question from online. How do you address the problem of newly added products with the user clicks or add to cart data has not been accumulated for yet? They may not be at the top of the search results while being actually relevant.
So we give it time. We wait until someone finds this product and then until someone else finds this product as well. But we also have normal search, by the way. We also have documents that we analyze and fields. So there's also a chance that these products will just show up at some point. I wouldn't call it organically, but they do if these products have enough data.
Hi, you were talking about these micro sessions, and I find the idea really interesting. But one problem that I see with this is, how do you determine what is actually a micro session? How do you cut these, and how do you make sure that you haven't cut off some events? For example, when someone searches for something, how do you determine if they are now refining this term or if they have given up and are searching for something completely different?
Yeah, well, this is a good question that we actually have not addressed yet. It was just making up things like, okay, we're gonna do 2 minutes. That sounds plausible, and that introduces the risk that you're excluding some events that are actually relevant. But at the same time, it seems like we're already including a whole bunch of events that are relevant and learning from that. And I think there's, we can optimize this, but we haven't gotten around to it yet. But good point, though.
Thank you.
Okay.
Understand what actually the intent is, so we can better match these sort of sessions, or at least understand what a complete session is. But that's really, that's something we hope.
It's really cool that you already had some uplift, even though you're just, you're not sure yet.
A low-hanging fruit, I guess.
Great. So one more question online. I think we may have time for one more from the floor. I'm sorry, we're not going to get to everyone. Matthew asks, with the correlation scores that you have between query item pairs, have you considered using those scores to boost highly correlated pairs higher rather than just a threshold for indexing?
Thanks for the idea. I think I'm definitely going to steal that. We're not doing this, but I like these questions that are actually statements. So thank you for the statement. Let's do it. That's a great idea.
Okay. Eric, I think your mic has died, so you may have to use the handheld for now. Okay, so we had one more question from the floor. If you all stick your hands up, who's got a question, I'll make a random. Yeah, I'm going to go here because it's closer. It's been a long day.
All right. Thank you. Thank you for the talk. It was really interesting. Yes. What I think is, I'm working in e-commerce, and our customers are way more spoiled, if you will, with all this competition, etc. But your customers has a strong incentive to actually buy something, and this might lead to some, like if you squeeze Elasticsearch enough, you might get the correct result with the wrong way of doing it, right? With some random search term, which is not exactly correct, but returns what you want. And then this might become a trend. And then you might actually think that this is something that will produce the result, but it's actually wrong. In terms of returning the result, this is okay. But first of all, have you ever encountered this sort of situation? And second, does it really impact the other queries when you do something like this? It's kind of a self-fulfilling prophecy. They're searching something like random and then getting a result. Now it becomes a thing with your implementation. And what are the impacts of this?
Yeah, so what you're saying is basically there's a risk that someone does something that is totally incorrect, and we add it to our sort of knowledge base nonetheless, because it happens, we see it happen. But yeah, so the safeguards that we have against that is that, you know, how all our customers are companies, they're organizations. And we find it, this is also based on common sense, we find it very unlikely that two companies are that are actually our customers are gonna conspire against us to put this garbage into search. I think, you know, it's a matter of trust and also making sure that we need to observe this at least in a minimum amount of different companies that are searching. And yeah, so the moment 3 companies start conspiring to mess with us, then we are done. Yeah. Oh yeah, we also.
So that's why we did invest in the possibility for people in the business, and mostly product specialists, to yeah, we call it suppress search result, but they're able to say, okay, this result just shouldn't show up for this specific query. And that's that feedback loop that I was talking about, but it also just blocks that search result. So we know, okay, this you know, this mapping that we created, that shouldn't have been there, and we get it out of the search. So if indeed there's really this problem happening, yeah, there's still a lot of our specialists, they use the web shop every day also when a customer's calling. So we do have that feedback coming in.
Right, we're going to have to bring this to a close. Eric and Jelmer, thank you so much.